All right, and welcome to the closing sections of Chapter 10. We have 10.6 Part 2, and then we have 10.7. You should, in your possession, have approximately 7 pages of notes up to this point, from 10.1 through 10.6 Part 1. Okay, and I will actually be checking those on Wednesday. But it should be important that you know these are the notes that you should have in order to be able to do the work. Remember, you have all the way up until next Wednesday to actually turn in any late work, and your test will be Wednesday. Okay. All right, we will have an assignment that's due over the weekend so that we can review on Monday. There'll be an online review session Tuesday at 7:30. I look forward to seeing you guys there. All right, so when we talk about 10.6, Part 2, we're still dealing with circles, okay? Except this time, we're dealing with the circumference of a circle, okay? And circumference of a circle is diameter times pi. Relatively easy formula. Now, they do give you two of these. They give you or circumference is 2 pi r. Now, hopefully you understand why it's 2 pi r and this one's diameter pi, because a diameter is 2 radiuses. Get it? Diameter and then 2 radiuses make a diameter. So they are the same equation. I will tell you that most equations always use radius. Why do they throw diameter in there? Because you have to remember to either cut it into 2 equal pieces or double it. All right? This is another formula that's given to you on the reference sheet, so you don't have to remember it. But by use, you should start to memorize it. All right, and then we get into some definitions. The first one is a picture. It's called a concentric circle. And for your purposes, you'll probably just need to know what one looks like. Okay? There is a definition to it. Okay? Concentric circles share the same center. That's basically all it is. So that means the center of the smaller circle is also the center of the bigger circle. All right, so understanding that concentric circles share the same center. Okay, and you know what it looks like. It looks like a bullseye, a dartboard. You've seen concentric circles all over the place. So it's an important concept to know what it is. If they tell you have concentric circles, you should be able to draw the picture. All right? So those are the two main things they're talking about. So let's look at a sample problem. Let's pretend you have a railroad track and they want to know it goes in a circle at the mall, okay? Which means you've got, hopefully you know how a railroad track is, and there's ties that go here and the train goes around and Santa sits in the middle, okay? Most of you have seen this type of display at other places or in the mall. Okay, and it's telling you that the distance to the train track is 8 feet, but the track is 2 feet wide. And it says, find the distance around the outside of the track. So you would find the circumference of 2 pi r, and that's the one I have a tendency of using all the time because I know that the radius is something I have to keep straight in my head. And you should know the radius is from the middle to one of the sides. Now, what can they do to make these pictures confusing? They'll move this 2 measurement to the other side. They'll put it up top. You have to understand that it moves anywhere it wants. I put it right next to it so you can see it right away. So hopefully you know that the radius, we need the radius of the big circle because we need the outer side. Okay, so that would be correct. 2 pi 10. All right, which comes out to 20 pi. Now we leave it in terms of pi. Okay, this is why you have that fancy calculator, because it'll keep it in terms of pi as well. You don't multiply by 3.14. That's a middle school trick. We don't do that anymore. Okay. All right. And if they wanted the circumference or the distance around the inside of the track, well, then I do the circumference of 2 pi r. And this time, instead of 10 putting in, I would do 2 pi 8, which is 16 pi. Now, the only thing that changes in these problems is the question. Understanding how to do the math is not too difficult. Now notice, we've talked about this in the past, that when you have a shape inside of another shape, there are going to be times where you're going to have to subtract. When you have a shape next to a shape, you would add certain things. Well, in this case, let's say I ask you a question like this. What is the difference between the inner wheel traveling and the outer wheel traveling? Well, hopefully you know they're inside of each other, so whatever the distance around the inner, I subtract from the outer. So basically I've still done the same work, except here I minus the 2, because I'm trying to find the difference. And the difference is an answer to a subtraction problem, which means the outside track is 4 pi feet longer than the inside track. All right? Okay. If you have any questions, you're more than welcome to write them down and share them with me. What I'd like you to do now is I'd like you to do the got it problem. So you do the problem, have it done, and I will check it with your notes on Thursday. Okay, now that you're back, we're going to go over arc length. Now this one's a little bit tricky. Notice the measure of an arc is always in degrees. Arc length is the distance or piece of the circle. So in other words, I'm trying to find the distance from one piece to another piece. Okay, right here. I'm finding the distance. Now, it involves finding the arc measurement. What? Yes, exactly. It's a percentage of the circle. So if I know the whole circle is how many degrees, if I can figure out what the measurement is, then I can figure out what the arc length is. Okay, so let's just do one by example. Let's say that's my diameter, and it's 16. Okay, and I say that I would like to find the arc length from A to B. Now, first of all, is that a major arc or minor arc? Correct. Hopefully you know it's a minor arc. And you should be able to tell me what the arc measurement is. Right, the arc measurement is what? 90 degrees, right? Because your central angle and your arc will always be the same. So whatever measurement is out here is the same that is here. If this is 90 degrees, then the arc measurement is 90 degrees. So I would put the degrees over degrees because everything has to match. And then I put the arc length, which I don't know, over the entire circle. Notice 360 is the whole circle, so I need the whole circle, okay, which would be 2 pi r. Okay, and then our good friend cross multiply and solve is what comes into play here. But setting it up is the hardest part. Once you understand where everything goes, then it's just cross multiplying and solving. Kind of like using area and perimeter ratios. Once you know which ratio you're using, and usually it's never the one you originally find. In other words, you start with perimeter ratio. They don't ask you for the perimeter ratio because the perimeter ratio is what you start with anytime. Okay, and then you square root it, or excuse me, square it, and then you get the area ratio. Or they give you the areas and they want perimeter. You usually end up squaring or square rooting before you cross multiply. And again, here we're trying to find the measurement. This number will never change, and this formula will never change. Those always stay the same. 360 on the bottom, 2 pi r on the bottom. All right, so we're looking at this, and my radius would be 8. This means it's 16 pi. So I would do 16 pi over x, because I'm trying to find this measurement, equals 90 over 360. You cross multiply and you solve. Now those of you who have higher end math skills, you know that 90 of 360 is 1/4, so you could reduce that. 1/4 of 16 is 4. So this would be 4 pi. So the length of the arc is equal to 4 pi. Okay. So will they always give you the measurement of the arc? Yes. Sometimes indirectly, which means, let's take, we have a circle, and they might give you this arc of 240 degrees. You should be able to figure out what that arc measurement is. What is it? Correct, it's 80 degrees. Some of you are going, 80 degrees? How would you get 80 degrees? Am I right? Is it 80 degrees? Well, what happens if I put 80 and 240? What do I get? Is that what a whole circle is? Hopefully you already caught the mistake and you go, well, Mr. Fraser, this has to be 120 degrees. Because what do the two arc measurements have to add up to? 360, because it's a complete circle. Now, does that look like a 120 degree angle? No. But guess what? It is. Why? Because the picture says so. Not because of how I drew it. All right? So you might have to indirectly find pieces of the circle before you use this formula. This formula is not on the reference sheet. So you have to understand that you're going to be doing the cross multiplying and solving and memorizing that all by yourself. The key is making sure you use the measurements you're supposed to use. So if they need arc, let's say I do this, what's that measurement going to be? Okay, well, I see a diameter, which means the circle is cut into 2 equal pieces, which means the top part's 180, the bottom part's 180. So what happens if I need this piece from here to here? Hopefully you know you do 180 minus 120, and that would give me this piece of 60. Okay, so it is important for you to be able to find missing arc lengths, arc measurements. Okay, arc measurements are always the angles, as well as the degree measurements. So it's important you can rationalize that. I will tell you that I always look for a diameter, because a diameter is giving me information I know. The circle's 180. Then I break it down from there. I find all those pieces first. Once I find those pieces, then I turn around and solve the equation. All right? So what I'd like you to do would be the got it number 4. And then you can check that answer when you get to class on Thursday. All right? Last but not least is the concept of congruent circles. You should know that when circles are congruent, then their arcs are congruent. If their arcs are congruent, then the circles are congruent. Okay? So you're trying to compare two circles. they have the same arc measurement, and if they have the same arc measurement, then you're dealing with congruent circles. All right? Have a good time.